Today's lesson is going to focus on solution chemistry and some of the calculations that we need to calculate concentration. So you will go into our third unit here, which is quantities in chemistry. We have already touched on the concept of the mole and particles and mass. And now what we'll do is we're going to scroll down and we're going to move into lesson 6, which is on solution chemistry. And specifically today, we're going to talk about percent concentration. So you'll click on the what do I do, and this takes you through everything. You're going to open up the summary note. So I have a summary note here for you. And as usual, we're going to read through the main resource note that is provided. You're going to answer these questions to help you understand the concepts. And then down here, we're going to do 2 examples together. And it says here, watch my Loom video to help you understand those 2 examples. And then there are 3 questions for you to try that you're going to submit to the portfolio for me, and I will give you feedback. So I trust that you have already gone through all of this, okay? And that is important because there's terms and ideas that we need to understand before we can do these 2 examples. So if you haven't gone through the first part of the main resource note and the summary note, stop now and do that. If you have completed that, let's go on and let's talk about these 2 examples. So in the what do I do, we also have our main resource note listed here. So I'm just going to refer to this for a second. So we're going to use this note for the next few lessons as usual. There's some good background on breathalyzers and how they measure concentration of alcohol in your blood. And then we get into solution chemistry. So we talk about the different kinds of solutions. This is important that you go over this. These are ideas that you would have learned in junior science, but we need to review. I want you to do this, okay? Go through those 9 examples of solutions and guess what they are. We know that solutions have to be made up of a solute and a solvent, okay? So the solute is always in a smaller portion, and the solute is always dissolved into the solvent, and the solvent is in a larger proportion. And it doesn't always have to be liquids and solids, okay? It could be liquids, 2 liquids, it could be 2 solids, it could be gases also. But together, the solute and the solvent are called a solution. So we're going to come down to the calculation portion right here, and we're going to start to talk about percent concentration of solutions. And this is an important idea because this is how most solutions are represented in retail. Okay, so what do I mean by retail? I mean, if you go to the hardware store or the grocery store and you buy a solution of something that is classed as a chemical or has a chemical in it that is considered a little bit harmful, the manufacturer is required to put a percent concentration on the label. So here's an example of 70% ethyl rubbing alcohol. So they have to list that percentage concentration. And you'll see that on, rubbing alcohol, you'll see that on antifreeze, you'll see that on bleach, you'll see that on vinegar even. And so what does it mean? So if we come down here, we have our 2 formulas for concentration, and then we have our examples coming up. So I'm now going to move over to the Jamboard, and we're going to talk about this together. Actually, maybe I'll use green or blue today. Okay. So the formulas used to calculate percent concentration come in 2 types. There will be percent mass volume. And what that refers to is the mass of your solute divided by the volume of your solution. And when we do these calculations, because they are a percentage, we have to multiply the division or the divided values by 100%. You can also do a percent volume. And this is where now my solute and my solution are both in the liquid state. So you'd have a volume of solute that you are adding to a volume of a solution. And again, because it's a percentage concentration, we have to multiply by 100%. Now, one of the things we have to be very careful of with percent concentration is that the units have to be very specific. So please, please be aware that the unit for mass has to be in grams and that the volume in solution has to be in milliliters. Okay, they have to be. So if you are given a mass in kilograms or milligrams, you have to convert to grams. If you are given a volume in liters, for example, you have to convert to milliliters. Okay, you have to. And then for our second solution, both of these, because they're volumes, have to be in milliliters. Okay, so really this is very, very important. You have to make sure that your units match the units that I just showed you on this slide. And also it says that in the main resource note. Okay, so if we just flip over, you can see right here, I don't know if my cursor works. You see that the volumes are in milliliters, and note the mass and the volume is in grams and milliliters. Okay, and again, we have to multiply by 100 in order to get to the percentage value. So let's put this into practice and let's do an example. So it says vinegar is usually found as a 5.0% volume solution of acetic acid in water. A laboratory technician wants to make vinegar using pure acetic acid. How much acetic acid must he add to water to make 600 mils of vinegar? Okay, so we know the concentration. Okay, so our percent, we know it's 5.0%. And this volume of vinegar, this is my volume of solution. Okay, so I'm just going to write here volume of solution equals 600 milliliters. So we want to know what is the volume of our solute. We don't know what that is. So we're going to set up our formula for percent volume, which is equal to the volume of solute in mils divided by the volume of solution, also in mils, times 100. Okay. So what we're going to do is, because we know the percentage concentration, we're going to do the 5%. We're going to put it in there. And I'm going to immediately divide by 100. Okay, remember that we multiply by 100 to get to a percentage value. But when we are given a percentage value, we have to divide it out by 100. So let's do that right off the bat. And then we are asked to solve for the volume of our solute. So we're going to leave that alone and we're going to divide by the volume of solution, which we already know is the full solution of vinegar, which is 600 mils. And double check that you have the right unit, and we do. They gave us the volume in milliliters. So what we're going to do is we're going to solve for the volume of our solute, and we're going to cross multiply 600 mils over. Okay, so we're going to take 5%, we're dividing that by 100, and then we're multiplying by 600 mils. And what answer do we get? So you should follow along with me on your calculator to ensure that you are getting the exact same answer as I am, because everyone's calculator is a little bit different. We have to make sure that we know how are we getting these numbers. And if you don't get the number that I post here, keep trying, okay? And then contact me if you need any help. So I'm getting an answer of 30, and this would be milliliters because this is the volume of solute. Let's do the next example. It says a common saline solution. So that's a fancy word for a salt solution, saline solution, that is administered intravenously. Okay, so that would be somebody in the hospital who's hooked up to an IV. Okay, so a needle that is delivering this solution. It says that it should be 0.9% mass volume. Okay, so I can tell right away when I see mass volume, means my solute is going to be a solid and I need a mass of it. But overall, this is a liquid solution. A nursing student mixes 5 grams of salt into water to create 250 mils of solution. It says, is the percentage of the solution that the student made equal to 0.9% mass volume? If not, what went wrong? Okay, well, what we have to do is we have to figure out if this is 0.9%. So let's set this up, and we're going to take percent mass volume equaling the mass of our solute in grams divided by the volume of our solution in milliliters times 100. So they've given us the solute right here. Okay, it is 5 grams. They're saying right here, this is 250 mils of solution. Okay, use short form sometimes for solution. And let's divide those out and see what we get. So we're going to take 5 grams. We're going to divide by 250 mils of solution times 100%. And I am going to get, and you're going to follow along with me, 5 divided by 250 times 100. And I'm getting a 2% mass volume solution. Okay, so I am not getting 0.9. And it says, well, what went wrong? Well, I don't know what went wrong. He must not have calculated the right amount of salt. And I can tell, right? We're supposed to have 0.9%, and we have 2, which means that we have too much of the solute. Okay, we have too much of the salt in that solution. So, I don't know what went wrong, but clearly his math wasn't good, and he didn't calculate the proper amount of salt. And we should be adding a little bit less salt or a little bit more water, right? It's one or the other in order to get 0.9%. Okay, so you have 3 to try in the main resource note that you're going to upload to the portfolio. Give those a go and be in touch if you need any help.